All right, today we're going head-to-head with a real beast of a math problem. Seriously, this thing looks like it could be the final boss in a video game. But our mission is to crack it open, piece by piece, and show you the simple idea hiding inside.
Okay, so take a look at this. This problem comes from an exam that's legendary for being ridiculously hard. And at first glance, yeah, it looks like a total nightmare. You've got summations, you've got trigonometry. It's a true supervillain of a problem. But you know what? Every villain has a weakness, and we are about to find it.
Right? I mean, looking at this function f of n, it's just so dense. There's a massive sum on top, another one on the bottom. It feels like it's designed to make you panic. But we're not going to panic. No. We're going to investigate.
So our first move is to put this function itself under the microscope. We need to figure out what f of n is times really saying before we even dream of trying to test those options.
Let's be really clear about our game plan here. Trying to brute force the calculations for each option is a total trap. That's what they want you to do. Our real mission, our primary goal, is to simplify this monster function down to something we can actually work with.
And here's our secret weapon, our decoder ring, if you will, the product-to-sum identity. It's this awesome little trick that lets you turn a messy multiplication of sines into a nice, clean subtraction of cosines. And it just so happens to be the perfect key for that crazy numerator.
So check this out. When we use this identity on every single term in that numerator, something kind of magical happens. We create what's known as a telescoping series. Think of like a collapsible telescope, where all the middle pieces just slide away into each other. That is exactly what happens here. Almost every single term cancels out its neighbor, leaving just the very first bit and the very last bit. It's just beautiful.
So, with the numerator totally tamed, we can turn our attention to the denominator. It's another summation, this time with a bunch of sine-squared terms.
And luckily for us, there's another well-known, super powerful identity for this exact scenario. It turns out that the sum of sine squared, for these particular angles, has a stunningly simple answer. For a sum that goes up to n-1, the result is just n over 2.
Now, in our problem, the n in that formula is actually n plus 2. So, when we apply that identity, that entire messy sum in the denominator just collapses. It simplifies right down to n plus 2 divided by 2. Simple as that. And now, for the big reveal, the moment of truth. We take our simplified numerator, our simplified denominator, we put them together, and after all of the smoke clears, that entire monstrous, terrifying function boils down to this. F of n is just cosine of pi divided by n plus 2. I mean, how incredible is that? It's a perfect example of how sometimes the most complex things have a really simple core.
Okay, so now that we've unmasked our function, the game is completely different. We're not fighting some crazy summation anymore. Now it's just about plugging a few values into a simple cosine function. So, let's bring in the suspects, shall we? Options A, B, C, and D are coming in for interrogation.
First up, we have suspect A. It looks pretty complicated, with the inverse cosine and a sine wrapped around everything, but with our powerful new tool, this should be a piece of cake.
Let's just walk through it. First, we need f of 5. Using our new formula, that's just cosine of pi over 7. We substitute that back into the expression, and look at that, the inverse cosine of a cosine. They just cancel each other out. That leaves us with the sine of 7 times pi over 7, which is, of course, just the sine of pi.
And the sine of pi is 0. So the statement in option A holds up perfectly. This suspect story is true. It's correct.
All right, next in the lineup, we have suspect B. This one is way more direct. It's making a very simple claim about what f of 4 is equal to.
Yeah, this is going to be a quick one. We just plug 4 into our simplified function. That gives us cosine of pi over 6. And if you remember your basic trig, you know that's exactly the square root of 3 over 2.
So option B is also telling the truth. That's another correct statement. And this is a multiple correct question, so that's totally possible.
Now, suspect C throws a curveball at us, a limit. It claims that as n gets infinitely huge, our function, f of n, gets closer and closer to 1/2. Let's see if that story checks out.
Well, here's where the alibi falls apart. As n shoots off towards infinity, that fraction inside the cosine, pi over n plus 2, gets smaller and smaller and smaller. It approaches 0. So what we're really calculating is the cosine of 0, which is 1. Option C claims the answer is 1/2, but our math clearly shows it's 1. That is a direct contradiction.
And there we have it. Suspect C is lying. This statement is flat out incorrect. We've found our first false option.
Finally, we've got suspect D. This one looks like they tried to throw the whole kitchen sink at us. It defines this new variable, alpha, and then claims it's the solution to some quadratic equation. This one's going to take a few steps to check out.
Okay, let's follow the evidence carefully. First, we find f of 6. That's cosine of pi over 8. So that means our alpha is the tangent of pi over 8. Now, you can use a half-angle identity to find its exact value, which turns out to be the square root of 2 minus 1. The last step is to plug that value into the equation they gave us. And I know, it looks messy, but after a little bit of algebra, everything cancels out perfectly and it all simplifies to 0.
The equation holds. So, suspect D, even though it looked all scary and complicated, was telling the truth the whole time.
Correct. And with that, our investigation is complete. We've interrogated all 4 suspects, we've gathered all our evidence, and now it's time to lay out the final findings.
So, to summarize the whole case, options A, B, and D were all proven to be correct through our analysis. Their stories checked out. Option C was the only one that was definitively incorrect. The case is closed.
So, what's the big takeaway here? It's that the path to solving this thing wasn't about doing a million calculations or using brute force. It was about finding the right tool for the job. That single, elegant simplification of f of n was the master key that unlocked everything else, turning an impossible-looking problem into something totally straightforward.
And it really leaves you with a final thought, doesn't it? This problem looked like a mathematical monster, but underneath it all, it was just a simple cosine function. It makes you wonder, how many other challenges in life that seem impossibly complex are really just waiting for us to find that one simple, elegant key?